So here, the capital F is an antiderivative of F. There are different ways to write this, yes? So this means that integral of f of x dx is capital F of x plus c. Or you can say that this is equivalent, saying that f prime, if you differentiate the antiderivative, you will find the function lowercase f. Okay, so that's the information given. Now the question is asking find the given indefinite integrals. I know that I can do separate these guys. There is a constant, I can take it out, minus integral of x dx plus integral of 1 over x dx. Integral of lowercase f dx is uppercase f. You may say that, why didn't you put that plus c there? You know, when you're integrating or finding antiderivatives, you can ignore all the constants and put one big constant at the end. That's why I won't put for c for each one of these guys. That's x squared plus 2. And antiderivative of 1 over x is, or integral of 1 over x is ln absolute value of x. Now I will put just one big capital constant c, just to deal with the constant part of those antiderivatives. Okay. For this one, we have integral of 4x dx plus 3 integral of sine x dx. I know that integral of f of x, lowercase f of x, is capital Fx. But what about, in other words, derivative of Fx is equal to this guy? Well, what will happen if I do find the derivative of capital F evaluated at 4x? In that case, I will get 4, remember the chain rule, f prime, which is lowercase f, evaluated at 4x. And this is the same thing as saying f integral of f of 4x dx. This 4 is constant, I can divide it to the other side. It's 1 over 4 capital F 4x plus c, and that is what we have here, plus integral of sine x is negative cosine x. So I will write minus 3 cosine x plus c. These two last examples are a little bit trickier. What we need to see here, note, is that, well, here I have f of x plus, I know that lowercase f is the derivative of capital F. And I need to see that this lowercase f, I can write it as 1 times f. Why is important? Because that way you can see easily that this is the derivative of x times f of x plus x times capital F prime dx. And now you have to be able to see that this is integral of a derivative of product. This is product or derivative of first one, which is x, times the second one, and then you're trying to find antiderivative of that. Antiderivative integral of f prime is always f. So this means that I have x, this plus c. In other words, I found a function whose derivative is this guy here, and obviously that is x times capital Fx plus c. Well, if you look at the second, the last example, you look for the pattern that appears in the quotient rule. And what is that? The derivative of the numerator, here, f prime is lowercase f, times the denominator minus numerator itself times the derivative of the denominator, which is cosine x, then the denominator squared. What we found here is that the integrand is basically the derivative of f of x over sine x. And that means that we found the antiderivative. The antiderivative is f of x over sine x plus c. As I said, these two last examples are a little bit tricky examples, but I am hoping that you are able to follow the argument here and see what is going on in the last two examples.